Okay, so what I would like you to do is I would like you to graph 1, 2, and 3. Please graph 1, 2, and 3. And then we're going to talk about them. These are absolute value functions, and we've already studied them. Okay. So let's talk quickly about how we would graph these as absolute value functions. Okay, for this one, the translation point moves to the point 3, negative 2. So we come right here, and then we go, the absolute value of 1 is 1, 2 is 2, 3 is 3, negative 1 is 1, negative 2 is 2, negative 3 is 3. And then we draw in our function, okay? And it would look something like, thank you, perfect. It would look like this. All right, how'd you do? Good? Yeah. All right, let's do the second one. All right, so this one is going to start at the point negative 5, positive 4. 1, 2, 3, 4, 5, up 4. Now, because this one is negative, it's going to open down. So it'll do the same thing, but it'll go like this. Okay? So this one's going to go this way. And this one goes this way. All right. And then the last one. The last one is just shifted down 2. And it has a 1/3 out in front. So we go up 1 over 3. Up 1 over 3.
She just said up 1 over 3. That's what I told you. Actually.
Okay. So, now that's what we learned when we graphed absolute value functions. But now today we're going to take this function that we already know, and we're going to kind of break it apart. And instead of thinking of it as a single absolute value function, we're going to think of it as a piecewise function where we restrict the domains. Okay, so you might not see it yet, but you're about to see 2 different lines for each one of them. The left side and the right side. The left side and the right side. The left side and the right side. Okay, so you didn't have to pick those colors, I just picked them so that you can see it's really made up, this absolute value could be thought of as 2 rays. So we could write the equation for one ray and restrict the domain, and then the other ray and restrict the domain. So absolute value can be thought of as a piecewise function. So what we're going to do on each one of these is I like to start with the left side. Now, since all of these are lines, we're going to try to fit it into our y equals mx plus b form, right? Because they're lines. So we're going to do the piecewise functions for each of these. All right, so let's do left side first. Y equals, the slope is down 1, right 1, down 1, right 1, down 1, right 1. What's the slope? Not just x, but negative x. Because I'm going down and right, it's negative 1. The slope is negative 1. Now, we can clearly see the y-intercept on this problem is 1. So there's our equation. Negative x plus 1. Now, this is just the left side. So it goes from negative infinity up to this x value. What's that x value right there? 3. Or we could say it's x values that are less than or equal to 3. So we could write it as an interval or an inequality.
But which one is better?
Which one is better?
Yeah, like more useful or something.
The second one you'll see on tests like the SAT or the ACT to get into colleges. The interval is what you'll see in higher level mathematics classes.
Oh.
So, I mean, they're both useful, but Just depends on where you're headed. Okay, now the second one, it is also a line, but the slope is up 1, right 1, up 1, right 1, up 1, right 1. So this has a positive slope, doesn't it? Now, right now, I can't see where it crosses the y-axis, but I could just kind of, if it kept going this way, where would it intersect? Down here at -5. Good. Now, this domain starts at 3 and goes to positive infinity. Or we could say x values that are greater than 3. Now, if you'll notice, I chose to do the included value, the equal to value, on the left side, and not for the right. And you can make that choice. You just choose to do it on one side and not on both. So it's included on one and not on the other. And it doesn't matter which way we go with that. All right, I did want to show you one quick thing with the inequality. So here is our vertex. So this green one exists on this side of it, right?
Yep.
Do you see how this arrow that I just drew matches my inequality?
Yep.
So it's going left, it's pointing left. This one exists on the right side, the pink one. It's going right, it's pointing right. Now, that doesn't really help you with understanding, but it is kind of a way to check and make sure that you've done it right. Okay, let's take a look at number 2. Okay, so let's take a look at this part right here, this green one. All right, so the slope is up 1, right 1, so that's positive 1. But I can't see the y-intercept right now. But I know right now I'm at 4. So this would be 5, this would be 6, this would be 7, this would be 8, so this would be 9. All right. Now, this domain, it extends forever left, so it's negative infinity until this x value. What is that x value? -5. So it's x values that are less than -5 because it's going left. On this one, I'm flip-flopping just to show you it doesn't matter. It could be equal to, it sure could. All right, the next one is down 1, right 1, down 1, right 1, down 1, right 1 for the right side. So this slope is -x, and I can clearly see it crosses the y-axis at -1.
Why isn't it x?
Because it is decreasing from left to right, so the slope has to be negative. Now that is x values from -5, and I'll include it this time because I chose not to here, to infinity. X values that are greater than or equal to -5. All right, I want you to try number 3, and then we're going to tie some things together, and I'm going to show you another method too. It's very handy. Okay. So the left side, down 1, left 3. Did you get a negative 1/3? And then x minus 2. And that is for x values from negative infinity up to 0, or x is less than or equal to 0. Now the right side was positive 1/3, and it is from 0 to infinity, or x values that are greater than 0. Now, a cool thing happens algebraically for each one of these. What you're going to notice is the left side ends up being opposite of everything in the absolute value. So let me show you what I mean by that. If I were to take this equation and just do the opposite of everything in the absolute value. So the x becomes negative, the 3 becomes positive. Do you see how I did the opposite of everything? And then I subtract 2 from that. I get this equation when I add like terms. Negative x plus 1. What did we get down here? Negative x plus 1. All right, let's take a look at this one. If the left side gives us the opposite, let's do it. So if we do the opposite of everything inside the absolute value, negative x minus 5, this negative makes all of that positive. And what is 5 plus 4? 9. What do we get? That's what we got. Okay? Well, what I did was the equation already had a negative out in front. Yeah. All right, this one. We're going to do the opposite of everything inside the absolute value. Well, the only thing inside the absolute value was a negative x. So my left side turns into negative 1/3 x minus 2. Is that what we had? Okay. So that is a great way to find your equation, especially on ones like number 2. That left side, that y-intercept was way up here, wasn't it? So that way is very helpful. All right, let's go do the right side. So the right side, what's in the absolute value stays the same. So all we do is change the absolute value symbols to parentheses and then combine like terms. Sometimes we have something to distribute, not on this one. So we end up with x minus 5. Is that what we got for the right side?
Yeah.
Yes. All right, let's do this one. All we do is change the absolute value to parentheses. So this time I do have something to distribute. I have a negative to distribute. So that gives me negative x minus 5 plus 4, which is negative x minus 1. What was our equation? Negative x minus 1. Okay, so this one, the right side. All right, we're done. That's all there was to it. And it matches. Okay, so that's a way to do it graphically and another way to do it algebraically. So to do it algebraically, for the right side, everything stays the same. Just switch those absolute values to parentheses, distribute, and simplify. But for the left side, we have to do the opposite of everything in the absolute value. Nothing else changes, just the opposite of what was in the absolute value. Distribute and simplify. All right. What kind of questions do you have about those two methods, graphically or algebraically? No questions? All right, let it set in tonight. If you have questions, you can ask tomorrow. Okay, so the last thing we have to do kind of goes backwards. But I want to go back and look at the ones we've done so we can see what's going on here. I want us to notice a few things. All right, first thing I want us to notice our translation point here, this x, did you notice that x is what ends up being part of our restriction? Did you notice this translation point x value ends up being the x used in our restricted domain? The x here, there's nothing, so it's 0, right? Ends up being the x here. So that restricted domain tells us what the x is at the translation point. Okay? Now the other thing I want us to notice, two things. The second thing I want you to notice is that on every single one of these problems, whatever sign this was is the same as the right side. That was positive, this one's positive. Whatever sign this was, negative, is the same as the right side. Whatever was here, positive 1/3, is the same as the right side, positive 1/3. So those are the two things we need to notice. That this x in the restricted domain is the x at the translation point. And we can find this leading coefficient and whether it's positive or negative by looking at the coefficient on the right side. Okay, so now let's look at these two. So less than gives us left side, greater than gives us right side. Less than gives us left side, greater than gives us right side. So we have to know that first. So we look at the right side. It's got a negative out in front. So when we work backwards and rewrite this as absolute value, because this has a negative, that must also have a negative. All right? Look at this restricted domain. That restricted domain tells me the x value at the translation point is what? 1. So in here it has to be x minus 1. Okay, now the last thing to do is to find whatever this y is. And the easiest way to find the y is to take this x and plug it into the easier looking equation. Which one looks easier to you, the top or the bottom?
Top.
The top. Okay, what is 1 plus 2? 3. Now we get the same thing if we plugged it into the bottom. Negative 1 plus 4 is 3. Same thing. Alright, now this second one's a little tricky. Because do you see my two equations? The top one is actually, which way is this one pointing? Right. So the top one is my right side, and the bottom one is the left side. So when I go to do my absolute value function, look at this right side. What is the leading coefficient? Negative what? 3. Negative 3. So we look at our right side, leading coefficient is leading coefficient. Okay, now we have to determine what the x is at the translation point. What is it?
X minus 2.
It is 2, so this would be x minus 2. Beautiful. And then we plug that 2 into whichever equation looks easier. Which one looks easier to you?
Left one.
The 3x plus 1. So we have 3 times 2 plus 1 is 7. And we are done, done, done. Okay, so you've got 10 minutes to start your homework, which is on the back. That should be, you should be really close to finished, maybe even finished before that bell rings. Please do not pack up early unless you have completed the assignment.